Okay, we are going to now take a look in section 1-2 at solving linear equations and rational equations. And first we need to recall what rational equations are. Every time you hear the word rational, you should think what? Yep, fractions. So these are going to be equations that have fractions in them. Dang, blasted fractions won't go away, but we're going to get good at them. But before we look at rational equations, we need to first look at those linear equations. And before we do anything, we need to recall what a linear equation in one variable actually is. Not too concerned about the idea that it's in one variable. We're kind of used to having just one variable, but it's more the idea of what does it mean for it to be linear. Can anybody recall what linear means? Linear is going to be a variable to the first power. If it's going to be second power, it's going to be quadratic. Third power will be cubic. Fourth power will be quartic, and so forth. We talked about that before when we talked about classifying our polynomials. So basically that means that all these equations are going to have one variable in them, and all those variables are going to be to the first power. So they're going to be pretty basic and easy to solve. They're essentially going to look like this. And what this means is that your A and your B are going to be numbers, and the x right here is what's going to be the variable. And notice that it is to the first power. So now what we need to do is we need to figure out how to solve those linear equations. And we're going to go right into it actually, and we're going to look at first how to solve a multi-step equation. And what happens with a multi-step equation is that the goal is to get the variable completely by itself. And what you have to do is you have to say, okay, if I knew what this variable was, and I knew the number that it represented, and I plugged that number in there, what would I do? You would follow order of operations, and then with your order of operations, you would either add, subtract, multiply, or divide, or raise it to a power. But essentially, if you knew what the number was and you plugged that number in there, then you would follow the order of operations to get your answer. What we're doing when we're solving an equation is we're trying to work our way backwards to figure out what that x actually is. So since we're doing things backwards, then that means we're going to reverse our order of operations, and we're going to kick it completely in reverse and do everything opposite. In other words, we are going to undo what has been done to the variable. And here's the key: in opposite order. In other words, let's take an example. Let's say that we've got, let's do a couple of examples here. And that pen is no good. Let me find a different pen. Okay, let's say I want to solve, and let's try 14n minus 8 equals 34. Now notice what I want is this n right here, and a lot of times I'll put a big old box around the variable that I want to have by itself. Then what I do is I say, okay, if I knew what that n was and I plugged that number in there, what would I do with it according to order of operations? Well, according to order of operations, I would take that n, I would multiply it by 14, and then I would subtract an 8. Well, the last thing that I said was subtract 8. So that's the first thing that I have to fix. I'm kicking it in reverse, completely opposite order. So the opposite of subtracting an 8 is going to be to add an 8. And what I do on one side, I have to do on the other to keep my equation balanced. And so that'll give me a 14n. Here's my wall. And on this side, 34 plus 8 will give me a 42. Now, once again, this n is what I want to get by itself. So I ask myself, okay, what do I have to do to that to get the n by itself? Very simple. I just need to divide by 14. And then when I take 42 and divide it by 14, I get a 3. Now, a lot of times some books will have you write your answer in a certain notation where it looks like this. Braces always mean set. And so what's happening here is you're generating a set of numbers. What we're trying to find out is what are all the numbers that we can plug in here for the n and do all the order of operations here on the left side and get it to equal or be the same as this right side. So the numbers that will work are this set of numbers. And in this particular case, the only number that's in the set is this 3. So sometimes books or teachers will have you write your answer in this case, where that means the set of numbers that will work is the set that has a 3 in it. Now, if you want to check this, in order to check, that means that n is going to be a 3, so that means you should be able to put a 3 right here where this n is. And like I said, do the order of operations over here, and it should be a 34. Well, 14 times 3 is going to be 42. 42 minus 8, sure enough, is a 34. And since 34 is 34, we know it's right. But remember, this is not your answer. This is what your answer is. Whatever n is going to be your answer. So that's one example of being able to solve a linear equation, a multi-step equation, in one variable. And now let's try another example. Let's say, for instance, this time that we have x divided by a -5 plus 3. And that's going to equal a -13. Once again, a lot of times what I'll do is I'll put a box around the variable that I want to get by itself. Here's my wall, and I say, okay, if I knew what this x was, and I knew the number value for it, what would I do with that? Well, order of operations says that I would divide by a -5 first, and then I would add a 3. Well, I'm kicking it in reverse. I'm completely undoing everything that's already been done to that variable. The last thing that I said was add 3, so that's the first thing that I fix. To undo adding 3, I'm going to subtract 3. Basically, the idea is I want to take that 3 out of the picture. I want to totally get rid of it. And so the way that I get rid of it is I subtract that 3 off. Now I'm left with an x divided by a -5 on this side, and on this side I'm left with a -16. Once again, here's that variable that I want to get completely by itself. That variable, if I knew what it was, then I would divide it by a -5. The opposite is to multiply it by a -5, so that's what I'm going to do on the left-hand side. And what I do on one side, I have to do on the other to keep my equation balanced. These will cancel out, and I'm left with an x equals a -16 times -5 is going to be a +80. So that's what x is. And once again, some of your books will have you write it in set notation, simply meaning that the set of numbers that will work is the set where an 80 is the only thing in the set. And again, to be able to check, all I have to do is take that 80, plug it right up in here where the x is. So I'll take the 80, divide it by a -5, because that's what order of operations says I need to do. And -80 divided by, positive 80 divided by a -5 is a -16. -16 plus 3, sure enough, is a -13. So the left side, in fact, does equal the right side. We know that it's right. Now those weren't too bad, but what happens when, notice that I had the variable only on one side of the equal sign. And in the previous example, again, I had the variable only on one side of the equal sign. Well, what happens when that variable is spread across the equal sign? Well, for example, it looks something like this. Let's say that we've got 4x minus 9 equals a 7x plus 12. Once again, here's that wall. Notice that in this case, there's my variable. Aha, there's my variable. It's spread across two sides of the equal sign. Well, based on what I know before, and one of the things I like about math is a lot of times we kick back to things that we already know. And so if I can get this to look a lot like the other two equations that I had solved, I know what to do with those. So if I could collect all the variables together on one side like the other two equations were, then I would know what to do with it. So sometimes that's what you have to do. When the variable is on both sides of the equal sign, for both sides of the equation, what you need to do is you need to get all the variables on one side and all the constants. Now the constants are going to be all the numbers that don't have variables with them. Get all them on the other side. Whoops. On the other side. So if I take a look at the equation that I just wrote down, then that means that I need to get all the x's on one side. It does not matter which side you get them on. Makes no difference at all. Just get all of them on one side. So let's say I want to move all these 4 x's out of the way. I want to get them off of this left side. I have to do the opposite of what's already been done. Since it appears that there's no sign here, then it's understood to be a positive, and the opposite of positive is negative, so I need to subtract that 4x off of this side. And what I do on one side of the equal sign, I have to do on the other side to keep things balanced. Now when I subtract that 4x, what I'm left with is a negative 9. Sign in front's a sign that goes. They're velcroed together, so this is a negative 9, and on this side, 7x minus 4x is a 3x. Now, once again, there's that variable I want to get by itself, but see, now it looks a whole lot like the ones that we had done before. So all I have to do this time is get all these constants, the numbers that don't have variables, since all the x's are on this side, get the constants over here on the other side. So I'm going to move this one out of the way, and once again, when I move across this wall, I have to do the opposite of what I see. So the opposite of adding 12 is subtracting 12. When I subtract 12, I get a negative 21. Now I'm down to just taking that x. I've already multiplied it by a 3, so I have to divide it by a 3. So now a negative 21 divided by 3 is a negative 7, and that tells me what x is. And once again, if I need to check it, all I have to do is take this negative 7, plug it in here and here, do the order of operations, and the left side should equal the right side. And if it does, then I know, in fact, I did it right. So let's check that. So I'm going to plug that negative 7 right in here. When I do the order of operations on this side of the wall, I get a negative 28 minus 9. And a negative 28 minus 9 is a negative 37. And on this side of the wall, a negative 7 times, or positive 7 times negative 7 is a negative 49. And a negative 49 plus 12 is going to be a negative 37. So sure enough, the left side equals the right side. So that means that the answer that I had gotten, yep, it is right. All right, let's try just a couple more because those aren't too bad. So let's say that I've got, how about this? 2 parentheses x minus 1 plus 3 equals x minus 3 times x plus 1. Once again, here's that wall. So what I want is to know what this x is, and I got a whole bunch of x's in there. And so you can see that they are spread across the wall, and I need to collect them all up on one side. So again, I'm trying to kick things back to what I've seen before, and I had all the variables on one side, but in order to move things across the wall, I have to do the opposite of what I've seen, or what has been done. But it's much easier to move things out of the way if they're completely simplified on either side of the equal sign. So before I start moving things around, because notice that back in this previous example, there were no parentheses on either side of the equal sign. It was as simple as I could possibly get it. There was nothing on this side that I could collect as like terms. There was nothing on this side that I could collect as like terms. So I need to make it look kind of like that. So what I'm going to do is, to make things as simple as I can possibly get them, is I'm going to distribute that 2 through. Because if I distribute the 2 through, then things are looking a little bit more simple on the left side. Not to mention that I can collect up these like terms here. So I'm going to collect those two, and a negative 2 plus a 3 is a positive 1. That looks really simple on that side now. So I'm going to try to do the same thing over here on the right hand side, get it as simple as possible so it'll look like that previous example, and I can get this x that I want by itself. So I've got a parentheses here, and I got to get rid of it. The only way to get rid of the parentheses is to distribute through. Now be very careful. What you're distributing through is what's up against the parentheses. Right up against it means multiplication. So what I'm going to multiply through is the negative 3. I am not going to multiply this x through because it's not right up against the parentheses. So I'm going to hang on to that x, but when I multiply the negative 3 through, I get a negative 3x minus 3. Now it's looking better, but I do have a couple of x's over here, so if I put those together, it'll be as simple as it can possibly get. So an x minus a 3x is a negative 2x. Now that does look a whole lot like the one we had done before. So at this point, what I'm going to do to get this x completely by itself is I'm going to subtract the 2x from both sides, because it doesn't matter which side you put your x on. That'll give me a 1 on this side, and on this side a negative 2x minus 2x is a negative 4x. Here's that x. Notice that it is all the variables are on one side of the equal sign. So that means I got to get all the constants on the other side of the equal sign. And now that means that this constant here needs to go over on this side. And when I go across the wall, I have to do the opposite of what I've seen. So to move this guy out of the way, I have to do the opposite of subtracting 3, and that's going to be adding a 3. So when I do on one side, I got to do on the other. I'm going to add 3 here, and that gives me 4 equals a negative 4x. Now, looking pretty simple at this point. All I got to do to get the x by itself is divide by that negative 4. And 4 divided by negative 4 is going to be a negative 1. That tells me what my x is. And once again, in order to check that, all you got to do is plug it back into the beginning, and if you get the left side to equal the right side, you know you've done it right. So I'm going to plug that negative 1 right in here. Order of operations says that here I got to do inside the parentheses first. Negative 1 minus 1 is a negative 2. And then I need to do my multiplication next. 2 times negative 2 is a negative 4. And now just add those up and get a negative 1. So if I get a negative 1 over here, then I know I've done it right. Once again, order of operations says do inside the parentheses first. Negative 1 plus 1 is a 0. Do the multiplication next. That gives me another 0, and negative 1 minus 0 is negative 1. Sure enough, it is right. And I know that my answer is right. Okay, so that's what happens when you solve basic linear equations. And in the next video, we'll take a look at what happens when you have fractional equations or rational equations.